Okay, welcome to day 7, and we're going to do more work with the particle motion where we're using those SFT equations to talk about how a particle moves on the x-axis, left or right, or sometimes you call them x of t because obviously they're moving back and forth on the x-axis. Okay, so displacement is basically your change in position. So if s is my position, my displacement would be delta s would be s at some secondary time minus s at some primary time. Okay, so that's how we figure out our change in position, and it could be a positive or a negative value. If you're moving to the right, your displacement has been a positive value. If you move to the left, your change in position is going to be a negative value. Okay, distance is not the same as displacement. Distance can only be a positive value. The distance from your house to Gilmore may be 5 miles, but your distance from Gilmore to your house is also 5 miles, because when we talked about distance, it's only a positive value. Another way to look at this is it is the absolute value of my displacement. So if I ran one lap around a track, I started here and I ran one lap all the way around, my distance traveled would be something like 400 meters, but my displacement would be 0 meters because my change of position is 0. I ended up where I started. So to be able to do something like that, I'm going to need to know when the particle is stopped and when it's moving left and moving right, and add up all the values together. And speed goes together with distance. Speed can only be a positive thing. It is the magnitude of the velocity. I made a mistake here. So it is the absolute value of speed is the absolute value of your velocity. Velocity could be positive or negative, but speed can only be positive. So how can we tell if a particle is speeding up or slowing down? Well, let's look at what we have. A velocity could be positive, or velocity could be negative. As example, I could have a velocity equal to positive 3, or I could have a velocity equal to negative 3. But then I have to compare that to acceleration. Let's say I have an acceleration that is also positive. Let's say a equals 2. This means my velocity is more positive than before. And if my velocity starts off positive and is getting more positive, I am speeding up. So for the next one, I have my acceleration is going to be negative. Let's say a equals negative 2. So my velocity is less positive, which means I'm slowing down. Okay, my velocity is still positive. You know, if you're driving your car and you hit your brakes, your acceleration is negative, but your velocity is still positive because you're still moving forward. If I have, again, a positive acceleration, let's say 2, well, my velocity, which was negative, is less negative than before. So that means I'm slowing down, because my velocity was negative 3, now it's going to be negative 2, then it's going to be negative 1. I am slowing down my velocity. The last one, I have a negative acceleration, which means something like -2, which means my velocity is more negative than before. And if velocity goes from -5 to -6 to -7, the absolute value is increasing, so I am speeding up. So if you see a trend here, you're seeing that these two go together and these two go together, because my summary of all this, let's see if I can move this, I'm speeding up when velocity and acceleration have the same sign. Either both are positive or both are negative. As long as they have the same. You either have that positive velocity and getting more positive, or you have a negative velocity and getting more negative. Either way, you're speeding up. And you're slowing down when the velocity and acceleration have opposite signs. Ooh, what the heck is that word? Opposite signs. Okay, which means one is positive and the other is negative. Okay, so let's do some examples. I give you a position equation, S of t equals 4t squared minus 48t plus 3 for t greater than or equal to 0, and my displacement is my delta s, which is s of 5 minus s of 0. And if I do plug this all in, so I plugged in 5 and 0 into my s equation, and to find the displacement or change in position, delta s is -137 minus 3. So my displacement is equal to -140. Wow, I do not like that. -140 feet, which means it moved left 140 feet. What is the displacement after 10 seconds? Well, it's going to be exactly the same, except now when I do delta s, I'm going to do s of 10 minus s of 0. So I figured out s of 10 was -77, so my delta s is -77 minus 3. So my displacement for this one is -80 feet, which again is that this particle moved left. So when is the particle stopped? The particle will stop when the velocity is equal to 0. So I need to take the derivative of s, and my velocity equation is going to be 8t minus 48. I'm going to set it equals 0. 8t equals 48. So t equals 6 seconds is when this particle is stopped. I can make a number line starting at 0, going off to infinity, and right here at 6 seconds, I have my 0. My leading term is equal to 8t, so it goes positive here and negative here. Now I can answer the question, was it moving left and right? And is moving left from 0 through 6, and is moving right from 6 to infinity. So now I need to break it down. Okay, now what is the distance it has traveled after 10 seconds, not the displacement after 10 seconds. That was part B. I needed to know the total distance, so I have to pay attention to my number line, except I'm going to stop it at 10. I have 6 here. I have negative and positive, so I have to break it down into doing time is from 0 to 6 seconds, and I have to do time is from 6 to 10 seconds. That's what I need to break it down to. Okay, at 6 seconds it stopped, so I'm going to break it down into 2 different parts, and I'm going to take the absolute value of those. So I did a lot of work off camera, and the idea is that I have to break it down from 0 to 6 seconds and then from 6 to 10 seconds, because from 0 to 6 seconds it will be moving left, and from 6 to 10 seconds it will be moving right. So that's what I did over here. Over here in red is my 0 through 6 seconds, and I got negative 144 feet, but the distance is just the absolute value of that, so that's 144 feet that it moved from 0 through 6 seconds. And then I did from 6 to 10 seconds, and I did all that work, and I saw that it moved a displacement of 64 feet, and the absolute value of 64 is still just 64. So my total distance traveled is adding up the 144 and 64 feet. So it traveled a total distance of 208 feet. Even though in part B, I'm going to shrink this up, in part B we saw the displacement was negative 80 feet. That means it moved left 80 feet. But the actual distance that it traveled to move left 80 feet was a total of 208 feet, because it's moving left and right. First it moved left, and then it moved back right. Okay, now I can go to the acceleration equation, which means I can just take the derivative of my velocity, and my acceleration equation is a of t is equal to 8, which means it's always equal to 8, which means if I make a number line from 0 to infinity, it's always positive 8. That means velocity is always increasing. Okay? So is a particle speeding up or slowing down at 5 seconds, and why? So I need to do the velocity equation at 5 seconds. I get 8 times 5 minus 48. I get my velocity at 5 seconds is equal to negative 8 feet per second. But my acceleration is always equal to positive 8 feet per second squared. And I notice that they have opposite signs, so it is slowing down, since velocity and A have opposite signs. So how about at 10 seconds? Well, at 10 seconds, let me grab my velocity at 10 seconds is going to be 8 times 10 minus 48. So my velocity at 10 seconds is equal to 32 feet per second. But I always have my acceleration. I should do 5 here. My acceleration at 10 seconds is always 8 feet per second squared. Now I notice that they have the same sign, so it is speeding up, since V and A have the same sign. Both are positive. So not only is it positive velocity, its velocity is increasing, which means it's speeding up. Okay, another example, we have a new equation for our particle. Its position on x is t cubed minus 4t squared minus 3t minus 2. It's in inches this time for whenever t is greater than or equal to 0. So I need the displacement after 2 seconds, which means my delta S would be S of 2 minus S of 0. And the other problem I'm going to do is the displacement after 8 seconds, which is delta S, is S of 8 minus S of 0. So as you can see, I did some work off camera. So I just did, after 2 seconds, I got negative 16 plus 2, which is negative 14 inches after 2 seconds, which means it moved left 14 inches. My delta S for the first 8 seconds was 232 inches, which means it moved right after 8 seconds. So when does the particle stop? Well, my velocity is equal to 0, so I have to find my velocity equation, which is going to be 3t squared minus 8t minus 3. And I'm going to set that equal to 0, which means I have to do some factoring. And I get 3t and t minus 3 plus 1. So I get t is equal to negative 1/3 and t equals 3. But it's really only t equals 3 because negative 1/3 is not part of what I had to begin with. I said I only going to use when t is greater than or equal to 0. T equals negative 1/3 is not part what I'm doing. So I can make a number line of all of this, starting at 0, going off to infinity. Here's 3, that's my 0. This is for velocity. My leading term is equal to 3t squared, so it goes positive, negative. So when is it moving left and right? It is moving left from 0 through 3, and it is moving right from 3 to infinity. Now I want to do the distance after 10 seconds. So because distance is the absolute value of the displacement, I'm going to have to break it up into 0 to 3 and then 3 to 10. So again, I broke it up into 2 time intervals. 0 to 3 is when the particle is moving left, and 3 to 10 is when the particle is moving right. So from 0 through 3, I saw my displacement was negative 18, or my distance is the absolute value of that, which is 18. And from 3 to 10, my displacement was 588, which is also my distance. I added these two together. I got my total distance was 606 inches that it traveled in the first 10 seconds. Now I can do the acceleration equation. Now this would be a little bit different because I do have a nice velocity equation here, so my acceleration won't be as simple as it was before. But now it's 6t minus 8. That is my acceleration equation. Okay, what I can do is make a number line. Again, I start at 0, go off forever to infinity. If I solve this, my acceleration is equal to 0 when t is equal to positive 8 over 6, or 4/3. So I have 4/3 right here. This is my acceleration number line. My leading term is equal to 6t, so it goes positive and negative. That will help me out. So I just copied my velocity and acceleration equation down here so I can see them. I'm going to know what's happening at 2 seconds. So v of 2 and a of 2, well, if I plug 2 in here, v of 2 is equal to negative 7, a of 2 is equal to 4, and these are opposite signs, so it is slowing down. I can do the same thing over here at 10 seconds. So v of 10 is equal to 217. A of 10 is equal to 52. And these are the same sign. So it is speeding up. So I have to ask myself, is it speeding up or slowing down at 1 1/3 seconds? So I gotta plug in, choose a different color. choose this brown. V of 1 1/3, or 4/3, I get -8 1/3, and V of 1 1/3, which is 4/3, if you recall from Airline, oh, not V, excuse me, A, and that is equal to 0, and this is neither. It's not the same side, it's not opposite side, it's doing neither. It's actually, we'll talk about it in a minute, but if you go back to that number line, go back to this number line, you can see here it goes -0, positive, so this is a min value for my velocity. Velocity is at a minimum. Let's see if I can spell correctly. Its acceleration is 0. And finally, last thing, when is it speeding up and slowing down? So I'm going to take these number lines that I did before, the velocity one and the acceleration one. I'm going to redraw them here. So the velocity number line started at 0, went off to infinity, and it had, here was the 0, and it was positive, negative. My acceleration number line looked like this, and I had right here at 4/3 was my 0, and I had positive on the right and negative on the left. So I have to see if it's speeding up, when does it have the same sign? And if I look carefully, from 0 to 4/3, they both have negatives, union with from 3 to infinity, they are both positive during that. So this particle is speeding up during those times. Okay, thank you for watching.